next example, we're going to look at a concept of thermal equilibrium, which means there is no transfer of heat from a hot surface to a cold surface. And we're going to use this through, again, an aluminum pan and some water in it. So, since the aluminum pan is the hot surface, we will say that the energy associated with the hot surface is going to be the mass of the aluminum times the specific heat of aluminum times the final temperature minus the initial temperature of aluminum. And similarly for water, it would be the mass of the water, specific heat of water, final temperature for water minus initial temperature for water. I should have put the subscripts on the temperatures earlier. Because of thermal equilibrium, the final temperature for water should equal final temperature for aluminum. That means there's no heat transfer. Also, when that is the case, then we know that the hot surface energy plus the cold surface energy add up to 0. That means that the energy that the hot surface lost was gained by the cold one, or vice versa. So since we have that equation, let's plug in what we know. The mass of aluminum, specific heat of aluminum, final temperature for aluminum, let's call it final temperature now because we know it's the same for aluminum and the water, minus the initial temperature for aluminum, which was 150 degrees Celsius, should equal minus the mass of water, specific heat of water, times the final temperature, that's the temperature for equilibrium, minus the 20 degrees Celsius, which was the initial temperature for water. And if we multiply this out, we get M for aluminum, C for aluminum, TF minus 150 degrees Celsius, mass of aluminum, specific heat of aluminum, has to equal minus the mass of the water, specific heat of water, final temperature of water, and then a negative gives us a plus 20 degrees Celsius times the mass of water times the specific heat of water. And if I isolate T final, I get T final from this expression. I can factor out T final and get mass of aluminum, specific heat of aluminum. And if I move this expression over to the right hand side and factor the TF, I get a plus mass of water, specific heat of water, should equal, now if I move this expression over to this side, I will get 150 degrees Celsius times the mass of aluminum, specific heat of aluminum, plus mass of water, specific heat of water times 20 degrees Celsius. So TF then is going to be this 150 degrees Celsius times the mass of aluminum times the specific heat of aluminum plus the 20 degrees Celsius mass of water specific heat of water all over mass of aluminum, specific heat of aluminum plus mass of water, specific heat of water. Let's go ahead and plug in the values, and we get 150 degrees Celsius. Mass of aluminum is 0.5 kilograms. Specific heat of aluminum is 900 joules per kilogram degrees Celsius plus 20 degrees Celsius times the mass of water, which is 0.25 kilograms, times the specific heat of water, which is 4186 joules per kilogram degrees Celsius, all over the mass of aluminum, specific heat of aluminum, plus the mass of water times the specific heat of water. And if we do this, we get that the final temperature is about 59.1 degrees Celsius.